Hi, this is a video on section 9.3, the very last homework of Algebra 2 here at STCC. And there apparently is only 12 questions in this section, so it should be a short one. But what we're going to be doing here is graphing. And a lot of people hate graphing. It shouldn't be that. The computer actually makes it very easy to graph. But let me give you a little background as to how to graph and what they're talking about here, graphing quadratic equations. Okay, this guy right over here, see this equation? And I'm starting in the middle of the homework because I have my own little technique I like to use to show you how to do this. But let me just give you the general format of what's called a quadratic equation. And this is, you can recognize this as something that we've already seen. Ax squared plus bx plus c. Okay. Before you set that equal to 0 in order to solve it, but now you're not setting it equal to 0. What you have here is another variable y. And whenever you graph anything, it doesn't matter. I know you did this in Algebra 1. You picked the value for x, you plugged it in, and solved for the corresponding y. You always generated a pair, x comma y, like so, where x is the horizontal coordinate, y is the vertical coordinate of that point. And it turns out whenever you have a problem with a square in it, you always get, say this is your graph, say this was your coordinate system, not very good, I'm sorry. You always get a graph that's a curve. Okay, it always looks like this, or it could go down as well. It's always going to give you a curve, and that curve is called a parabola. And if you thought math really didn't mean anything, there's no reason for math. It turns out that parabolas are actually used in real life. People have this direct TV, and this direct TV, they give you this little dish, and this dish you mount it on your roof or somewhere convenient. What happens is that dish takes signals that come from a satellite, and those signals come at this dish from space, and and basically what that dish does is it focuses all these signals to a point in such a way, and you'll notice in the middle there's always some sort of like a little gadget in the middle that sort of takes all this signal that's getting focused inside, and it goes off into a wire onto your TV set. Okay, it's like a collector. You could think of that parabola as a collector. It turns out there's a real reason, the real focus. So what happens is parabolas focus parallel beams into a center, and that center is your strong signal that goes off to your TV set. Well, that's nice. That's all well and good. We don't need to know about the physics of that. I just wanted to give you a little additional bonus as to why parabolas are important. So let's start over again. I guess it's probably best we start over again with a blank slate. Okay, start over here. File new. Okay. And we'll come over here and we'll put that equation again, the standard equation, which shouldn't be hard to really deal with. You always put your squares first, your x's in the middle, and your number at the end. Okay, and this looks pretty good. This sort of matches up. So I told you that we either have a graph that goes up or it goes down. Okay, I can tell you right now, looking at this equation right over here, I see A is -1, because that number in front of the x squared is a -1. Let me make it a little bit bigger so you could see it. Let's not make it bigger. Oh, plus. Okay, that's too big. Okay. So got A is -1, B is 2, and C is 3. Okay. What determines whether it goes up or down is the number in front of the x squared. The x squared is your dominant term. Plug in any number like 100. 100 squared is a big number compared to this term, which doesn't generate that much of a value. So it's the number in front of the x squared that controls what this thing does. And the fact that this is negative means it goes down. Okay, it's not hard to understand. Anything that's negative, you're depressed, you look down. Anything positive, if A is positive, you look up to the sky and you're happy, and it goes up. That's all you remember. So I expect this guy, if I were to graph it correctly, would be going net down. That's it. So I don't know where on the graph I go right now, but I know it's going to go down. And there's a little equation you have to remember. It's this equation right over here. Negative b over 2a. Negative b over 2a. It's sort of like that quadratic equation. Remember the quadratic equation? I said negative b plus or minus the square root of b squared minus 4ac all over 2a. Forget the square root. Forget the square root. This part here, negative b over 2a. What this equation tells you is where on the graph x, the vertex is located. This is called the vertex. Now, what am I talking about vertex? If the graph goes down, which I expect this one to go, the graph is this most important point on this graph is the vertex. Let me push it over here. Is the vertex here? It's the maximum value. Okay, the minimum value is when the graph goes up. These are called vertices, vertexes. The vertex is the most important point. It determines where on this graph it needs to be placed. This curve needs to be placed. It tells you that this equation tells you that the vertex is located at this x. Let me plug in those values. X equals negative b, so negative 2 over 2 times negative 1 is negative 2 over negative 2 equals 1. Negative 2 over negative 2 equals 1. I expect the vertex to occur at x equals 1, at the coordinate x equals 1. But that's not enough to graph anything, because whenever you graph something, you need not only an x, but you need a y. So far I have half the equation, half the point. 1. I got that point right there. The vertex, okay, the vertex is located at x is 1. Now, how do I find the corresponding y? Well, what you got to do is take the 1, plug it into the equation, and I really wish I typed that equation in. Well, I'll do it over here. Y equals negative x squared, this is the original equation, plus 2x plus 3. And what I'm going to do is everywhere you see an x, I'm going to plug in x in parentheses. Okay, I'm going to plug in the 1. See, x is supposed to be 1. Everywhere I see an x, I put a 1. And I make sure I put it in parentheses, so I do my order of operations. Okay, and the order of operations says I need to do my square first. You're not squaring the negative now. Understand that. This is why you need to put it in parentheses. The 1 is being squared. That happens to be negated. So it's not negative 1 in the parentheses. There's 1 in the parentheses. So your square 1 is 1. That gets negated. You get negative 1. There. So we did the powers. And then you got to do the multiplications next. 2 times 1 is 2. Copy the plus 3. And that gives you negative 1 plus 2. Negative 1 plus 2 is 1, plus 3 is 4. That's the y value. Y equals this calculation. X is supposed to be at 1. We know the vertex is going to occur at x value of 1. We put the 1 in this formula, to calculate the corresponding y, and if everything goes well, we'll graph something. So let's come over here. Okay, how do we graph? Here's how you graph. Click the graph. I just clicked the graph. Always pick this guy. Never mind, all this other stuff is a distraction. Always pick this vertical parabola tool. Okay, it's waiting for you to type something in. Look at this. So I'm going to start at the origin. That's the 0, 0 point. And the point that I want to graph is 1, 4. Or actually, yeah, 1, 4. So let's see. X is 1. Y is 4. Click. I registered 1 point. Now, notice it's looking for another point. See? It's looking for another point that I need to register. How do I get that second point? So far, you always try to calculate the vertex, but then you get to pick what the x value for another point, whatever is convenient. Pick another value for x. Plug it into here. I always try to go for an x value of 0 for your second point. Why? Because it's very easy to calculate. Okay, if x is 0, plug in 0. That means this term is 0. Square anything, you get 0. Negated, you get 0. Plus 2 times 0 is another 0. Plus 3, so there's your second point. Calculated with no effort. That's why I'm saying it. There's no reason. Oh, I think I screwed something up here. Okay. No, I didn't. Okay, so it's still latched on to that point. 0, 3. And I believe it even helps you if okay, there it is. Yeah. See, on the bottom of the graph, they help you with the actual location of the point. So remember 1, 4. You can't get this wrong. Okay, and then the second point, I picked 0, 3. Click it. That's a beautiful graph. Look at that. That graph is going down. I'm going to click check my answer, and I got an excellent. And you're going to basically do this for 5 or 6 problems. Okay, what's the next question? Okay, let's move this over here. Let's do a nice clean. Kill this. Don't save it. File, new. Okay. I'll move it over here. That's good. Oh boy, there's a little graph there. It's kind of scary. So let's come over here. Y equals x squared minus 8x plus 16. Okay, don't be afraid of all those little squares. It doesn't matter. You do it the same way. Let's see. What do we do first? Well, I can tell you right now this graph is going to go up. See, the number in front of the x squared is a 1. It's a positive number. It's going to go up. So that's one observation. I need to find the vertex. How do you find a vertex? What you're going to do is you're going to use this little equation here. X equals negative b over 2a. Okay, and let's take a look at this. A is 1, that's A. B is negative 8, that's B. That's an A. A is the first one. And C is 16. Well, we don't even care about C. It's not even mentioned in there. So all we care about is putting negative 8 as B. Negative and negative 8 is 8. Divided by 2 times 1. 2 times 1 is 2. 8 over 2, which is 4. So don't get too excited because all you've done is you've calculated half the point. We know the vertex is going to occur at x equals 4. But we need the corresponding y. Not hard to do. Here's your formula. Everywhere you see an x, you plug in a 4 in parentheses. Okay, so I'm going to put 4 in parentheses, squared, minus 8 times 4 plus 16. That's equal to y. You got to do your powers first. All right, you did the powers. Then you're going to do your multiplications next. That's negative 8 times 4 is negative 32. And copy down the 16, this other 16 here. So we got 16 minus 32 is negative 16. Left to right order, plus 16. It looks like y is equal to 0. Super. Super. Okay, that's 1 point. That's the vertex. That's the vertex. The next point, I get to pick the value of x. Okay, and pick some. You can pick anything you want for x. It will give you a corresponding y, but why do all so much work? Whenever possible, it's not always possible, but in this case, I can plug in x as 0. Okay, if x is 0, this squared is 0, minus 8 times 0, 0, 0, minus 0, 0, plus 16. Y's got to be 16 if you plug in 0, so put in 16. That's my second point, because in order to graph a quadratic, you need 2 points. So that's what I'm going to do. Plug in those points. Click the graph. Click the graph. Always pick vertical parabola tool. I'll pick the vertex first. Okay. Start in the center of the world. X is 4. You take a look down here. See this down here? It tells you what that point is. It's currently selected. 4. It's easy to move the mouse and screw it up, so don't get too sloppy. Okay, 4, 0. That's the vertex. Click it. Now the next point, I'm going to go in the center of the world, and I'm going to say 0, 16. 0, 16. Be careful. Don't move. See, if it's easy to move the mouse around. Be careful. Come there, 0, 16. Click. That's it. I got to believe when I check answer, I did it nice. Okay, we got 2 out of 10 done. Then you're going to miss this class. Okay, let's do this guy. Number 10. Number 10. Number 10. Let me kill this. Don't save it. File, new. Okay. New sheet of paper. And I'm going to write this equation down. But you know what? I'm going to write it like this because it doesn't look good, right? You know that from chapter 6. You got to put your squares first. Okay. Negative 2. That looks like a 1. That's a 2. Okay, that's a 2. That's a better 2. 2x squared plus 3. Okay. And then I know what I got to do. I got to find the vertex, right? X equals negative b over 2a. That's where the vertex occurs. Now I'm going to show you that a is going to be negative 2, right? That's a is negative 2. Okay, what's b? Now a lot of people say b is 3. B is not 3. 3 is the number at the end. B is the number in front of the x term. Okay? There is no x term. I could write this equation like this. Plus 0x plus 3. So be careful. Don't say b is 3. A is negative 2. B is 0. Okay? B is 0. See, when they don't give you all the terms, you got to stick in that 0x to get the 0. So I'm telling you, if I plug in x as 0, you get 0. And with b is 0, negative, if you could divide 0 by anything, you're still going to get 0. So that's good. That's not much to do. So the vertex occurs at 0x. I need the corresponding y. So what do you need to define for y? Everywhere you see an x, plug in a 0. You know, 0 is a great number. What you're going to do is you're going to come up here. 0 squared is 0. That wipes out this entire term. That's gone. 0. Plus 3. So I guess y has to be 0. It has to be 3. That's your vertex. That's your vertex right there. Now we need another point. Well, let's see, another point. I usually said plug in x as 0, but you can't plug in x as 0 because you've already used 0. You need another distinct point. The next best number is 1. Okay? You could put -8 in there, but why do the extra torturous work? What you're going to do is you say everywhere you see an x, you're going to put a 1. So this is the original equation. I'm going to say y equals -2 in parentheses 1 squared, that's this, plus 3. And everywhere you see, just do your order of operations. You got to do your powers. Now that squared is not touching that -2. That's 1 squared, so it's -2 times 1 plus 3. Okay, -2 multiplies out to be -2 plus 3 equals 1. So y is also 1. Okay, so those are your 2 points. The hard work is done. You got your 2 points. Should be very simple to see. Click the graph. Get the vertical parabola tool. Start at the center of the world. Let's see if we can get this up here. Yeah. 0, 0. Oh, no, I cleared it. I screwed it up. Start off. Okay, are you sure you want to continue? Yes. Okay, click on that. 0, 3. Boom, click that. And that's the point, 0, 3. Right there, 0, 3. And then the next point is 1x, 1y. Boom. And now, I'm liking what I see there because the x squared term has a negative number in front of it, and it's got to go down. So it's consistent. I'm going to go for it. Well done. Very good. Very, very good. What do you think? Well, this problem here, same stuff, only here we have a fraction. Don't be afraid. Fractions are good. Fractions are numbers too. Let me clear it. Don't save it. Start over again. File, new. Okay. Move this over here. This graph has got to go up because there's not much going down here. I see a number. The number in front of the x squared is a positive number. I don't care whether it's a fraction or not. It's a positive number, so it's got to go up. But where does it go? Well, here's what you do. Y equals 1/3 x squared plus 2. Okay? What's my a? Well, you guessed it. A is 1/3. What's my b? Don't say 2. B is the number in front of the x term. If there is no x term, it's implied to say that this equation has plus 0x. So b is 0. And I really don't care about that 2 because that 2 is always the c. Always the c. But so what I do is I write down my vertex equation where does the vertex occur? -b over 2a. And this is a situation where b is 0, so the top thing is 0. 0 divided by anything, who cares, is going to be 0. So I got half the point done, 0 comma something. 0 is the x value for the vertex. What's the y value? Well, you're supposed to take that 0, plug it in. 0 squared is 0. 1/3 is 0, still 0, plus 2. Well, there you go, plus 2. Y equals 0, 2. Now, I need to come up with another point. What you need to do now is say, well, don't try. The problem with fractions is it's not so much that you can't use the number 1. You can, but the problem is if I plugged in 1, I get 1 squared is 1 times 1/3 is 1/3 plus 2. You get 2 1/3. There's no way I can plot fractions on this. It's always whole numbers. So the key to doing this graphing with a fraction is pick an x value equal to the denominator. make it 3 when you have a fraction. X. So to get the y, what I need to do is plug in 3 for x. Y equals 1/3 times 3 squared plus 2. Okay, that's equal to, you do your powers first. Let's go down. 1/3 times 9 plus 2. 1/3 times 9, huh? 1 times 9 divided by 3. 3 goes into 9 3 times, so this is basically 3. 1/3 of 9 is 3. Plus 2 is 5. So if x is 3, y's got to be 5. Those are your 2 points. Let's see if they work. Click. Oh, let's see. Do they give us? They don't. Do they give us? Oh, we have to click the graph. Click this vertical parabola. Okay, yeah, there's your point helper. 0. I go in the center. 0, 0. X is 0 means you don't move horizontally, but you do go up 2. Click. Now I go into the center of the world. 0, 0 there. Then I got to go 3, 5. 3, 5. 1, 2, 3 x. 5 is up, 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 up. 5, 3, 5. Click that and check your answer. Great job. See? That's not bad. That's not bad at all. And we'll do this last one. It looks like a lot of words, but it's not too bad. Let me see if I can make it a little bit smaller, because unfortunately, I can fit that. I can fit that. Okay. And let's get a new sheet of paper going. Don't save it. File, new. Okay, nice and fresh. All right, so let's see, move this over here. Okay. Daily profit Y of a company varies with the number of products it sells each day, and it's given by this formula here. So what they're basically saying is plot this. Y equals, there it is, graph this equation. Y equals A, negative 0.2 x squared plus 30x. Okay. That's the first time we see decimals in a long time. Okay. This graph is going to go down. Why? Because the number in front of the x squared is a negative number. So it's going to go down. But what do we do to graph it? I need my A. A is negative 0.2 and my B is 30. Okay, I don't need C. We never need C. C is 0. If you don't see it, plus 0. If you did need it, but you don't need it. I need my basic formula for the vertex of where the vertex is going to be located, negative B over 2A equals negative 30. B is 30, negative B is negative 30, divided by 2 times a negative 0.2. So it's negative 30 divided by negative 0.4. And if I divide those two, the negatives will cancel. So we have 30 divided by 0.4 equals 75. I get x equals 75. And these are, you know, basically what they're basically telling you is you got to get out of your head that every number that you calculate in Algebra 2 is onesies and twosies. 75 is a legitimate number. Good. Plug that in there. Now, so far, I got the x value of the vertex. I need the y value too now. So everywhere this is your formula. Everywhere you see an x, you put 75 in parentheses. 0.2 times 75 squared plus 30 times 75. There you go. I should have. Where's my calculator? I need my calculator here. So what I'm going to do is do my powers first. 75 times 75 equals, that's what that is. Multiply that by negative 0.2. Multiply by, where's the negative here? Change, there it is, negative 0. Uh-oh, I think I screwed it up. Let's clear it over here. 75 times 75, okay, times a 0.2 negative equals, okay, all right, I'm going to write that down. Negative 1125 plus, now you got to multiply these two numbers. You got to do your multiplications before you add. Let's clear it. 30 times 75 equals 2250. And when I add those two numbers, I get a positive 1125. I don't need a calculator. So the vertex is Axis 75, 1125. Okay, that's 1 point. And believe me, the worst is over. I need another point. Okay, in this case, I can use x is 0. Okay, x is 0. What do you think y is going to be if x is 0? Take that 0, plug it into here. 0 squared is 0. This term goes away. 0 plus 30 times 0. Another 0. I get 0, 0 plus 0. Those are your 2 points. The wonders of 0. All right, let's plug these in. See what happens. 75, 1125. Okay. Click. Vertical axis. So is there? Yeah, there it is. 75 is over here. And unfortunately, I got to go all the way up. 11. Oh, geez. I can't see this thing. Okay, I can barely see it. 75, 1125. 75, 1125. You see that right down there? Right there. That's it. Let me scroll down a little bit. Okay. 70. Oh, geez. I got to clear it. It's not right. It's not right. Look at this. Oh, it's right. It's right. It's right. That's it. That's the number. 75, 1125. Luckily, 0, 0 is easy to get right there. That's 0, 0. Click. Check your answer. Great job. Yay. Now, B, how many products must a company sell to maximize its profits? Okay, to maximize the profits, you've got to be on top of the curve. That's the highest part right there. You've got to, so the highest part occurs here, and it's got a corresponding value of 75. So I'm going to say 75. Maximizes the profits. Check your answer. And is that it? Oh, continue. They snuck another question. Select a choice. Okay. Which of these is true? So if I start at 0, we make no money, no profit. But as I sell more things, I go up. So my profit increases to 75 products, but then decreases for sales of more than 75 products. I would say that. A, 75 and 75. And you know what? Actually, it makes sense, really. To sell more and more products, you have to hire more and more people. And when you start hiring more and more people, you're just not going to sell enough products to pay for their salaries and their health care and everything else. So there's a sweet spot in the middle for the number of people that you hire in your company. And apparently that sweet spot occurs when you sell 75 products. There you go. So what do you think? What do we got here so far? Well, we did those 5. Let's go down to 7. Okay, so after the worst is over, we did actually the hardest problems. Don't save that. Let's clear that. Let's try another one. New piece of paper. Okay, bring this over. You know what? I'm going to move this around. You know you're going to do that, right? Y equals negative x squared. And in fact, you know what? I don't see an x. I'm going to put plus 0x. That's a 0. X plus 10. Plus 10. My A is this guy. My B is that guy. 0. So the vertex occurs at x equals negative b over 2a. The wonderful thing about 0 is that you don't need any calculation. The vertex occurs at 0. X is 0. But what's y? Y. 0 is even better here. Look, this is what y equals. Y equals this calculation, but when x is 0, this term goes away, plus another 0, plus 10. That entire calculation is 10. Okay, we need another point now. Another point. How about if we do this? Pick one, the number 1. Pick x is 1. Everywhere you see an x, you put a 1 in the original formula. So this is what I'm going to do. Negative, in parentheses, 1 squared, plus 0 times 1 is 0. Don't even bother with that. Just add the 10, though. So 1 is squared, not the negative. So 1 is squared is negative 1 plus 10. And hopefully that's a number 9. Number 9. And those are your 2 points. Jeez, I'm getting this mouse pad is not, I got to get rid of it. That's 1, 9. Okay, let's click on this. Click. Click. Put that in there. Okay. Start in the center. 0x. Okay, that means don't move the mouse horizontally. Vertically, I got to go up 10. Now I got to do 1, 9. Move over 1. And keep going to 9, 9, 9. There, nope, that's 8. 9. Click. Click. Fantastic. Okay, we did that one. We're going backwards. We're going backwards now. Okay. Let me just see what's there. Okay. Clear this. I've got the coughs here. New, found new. Okay. Move over. How bad could this be? Y equals ax squared. Okay. X equals negative b over 2a. You know, rather than waste, you know, my mouse isn't working too well here. This is plus 0x plus 0. A, B, and C. A is 8. B is 0. There's a plus 0x. Forget about it. X is 0 for the vertex. X is 0. That's parentheses. X is 0. The corresponding y is also going to be 0 because when I plug in x is 0, 0 squared is 0 times 8 is 0. That's the vertex, 0, 0. Click. Click on this. Click that. That's 1 point, 0, 0. What do I do for the second point? Well, pick a value for x. You pick it. You can pick negative 100. You can pick 93. but that makes no sense. That means you got to do 93 times 93 squared times 8. Why? Just pick one. 1 squared is 1 times 1, 1 times 8 is 8. There's the second point. 1, 8. 1, 8. Okay, so we come over here. Where'd it go? Come on. Come on. Let's move this out of the way. 1, 8. Okay. 1. Okay, 1, 8. Right there. Boom. Right there. Check your answer. And only 5 more questions. Only 5 more questions. And 2 of them are actually, the first ones are, let's see, a vertical line. Okay, this is something that I need to talk about. Okay, come over here. If you have a parabola, we know what a parabola looks like at this point, right? And let's put it over here. Let's put it in the graph right there. There's your vertex. The vertex, okay, what the vertical line passing through the vertex, this is the vertical line passing through the vertex. That line's given a special name. It's called the axis of symmetry. Axis of symmetry. That's it. Final check. That's nice work. Okay. The idea being is, you know, you could, if this were a 3-dimensional graph, you could spin this cup around this symmetry. It's symmetric. The distance from here to here is the same thing as the distance from here to here. That's why they call it the axis of symmetry. Oh, we can answer this one. The parabola corresponding to the equation such and such opens upward when A is positive. You know, when A is positive, it's got to go up. If A is negative, it goes down. So only 3 more questions. Now, why don't we answer these things here? Given a parabola that has a vertex 0, 0, let's see. It's got to have a vertex 0, 0, and it goes through those points. They're giving you more information than you need. Okay, they actually gave you 5 points. You only need 2 points to determine the parabola. So let's take a look at this guy. This A can't be the answer because the vertex has to go 0, 0. This vertex is over here. That's not 0, 0. Okay, so forget about it. It can't be A. Okay. B could be the answer. B could be the answer. D could be the answer. See? Those are vertices of 0, 0. But C cannot be an answer. It's not at 0, 0. So it's a toss-up between B and D. What do we pick? Well, let's see if we can make it a little bit. Yeah. Pick another point. 1, negative 2. Okay. 1, negative 2. This graph can't be it. Okay. Because here we have, if we look at the tick marks, this is 4. This must be 2 and halfway. 1 is in the middle. And the corresponding point on that graph is a positive number, not a negative number. I'm leaning toward B because B, if X is 1, that's 4 from here to here, 2, 1's there, it's going down. It's got to match that point on the graph. It hits the graph there, it's a negative. So 1, negative 2, okay, I'm going to say B. I'm going to say B for that problem. Check your answer. See? There you go. B. B, B, B. Okay, now we've got just 2 more questions, and then Algebra 2 is done. You're done. Done, done, done. Question 4. Find the axis of symmetry in the vertex. Well, here's the deal. You need to find the vertex first to answer that question. The vertex is the thing that you always need to find first. So let's come over here, File, New. Okay. Move this over. Okay, so y equals 1/11th, strange number, x squared. Okay. Can you tell, from what we just said so far, what do you think the vertex is? I would think it's 0, 0. That's the vertex. Why did I come up with that? Okay, because I know the vertex always occurs at x equals negative b over 2a. A is the number in front of the x squared, 1/11. There is no b. B is 0 because there's no x term, plus 0x. If I stick in b, I get x is 0. And then I got to find the corresponding y, so I come over here, stick in x is 0 for x squared is 0. 1/11 of 0 is still 0. 0, 0. So, let's see. If I were to quickly graph this, okay, I would expect a graph that that goes up because it's got a positive number here. Okay, the axis of symmetry is this vertical line right here. It's this vertical line that goes through the vertex. Vertical lines are always x-equal equations. It's always x-equals equations. An axis of symmetry in this problem here, in this homework, is always going to be an x-equals because those are vertical lines. It's got to go through the vertex, and when it goes through the vertex, x is 0. So x has got to be equal to 0 for that. These other ones are y equals are horizontal lines, so those are distractors. This is the one. X equals 0 because the x coordinate of the vertex is 0. Fantastic. I think they're going to sneak another one, yeah. And so the vertex of the graph is 0, 0. So when you write this out, make sure you put the parentheses. Don't do 0, 0. Not going to be right. They want you to surround it in parentheses. Well done. And then the last thing, find the axis of symmetry there. Okay, here's what we're going to do. We're going to clear it out. Don't save. We're going to do File, New. Okay. Let's write that expression out. And you know that doesn't look right. Okay. These equations are actually easier when they give you all three parts. Okay, I find that people get those right more than if they leave out an x or they leave out a constant. So this is not bad. Let me move it around. X squared in front, minus 4x is in the middle, plus 24. They want you to find the vertex. We can do that. The vertex occurs at x equals negative b over 2a. What is b? B is negative 4. That's b. A is 1. So b is negative 4. Negative and negative 4 is 4 divided by 2 times 1. 2 times 1 is 2 equals 4 divided by 2 is 2. Now that's not the point. It just says x, the x coordinate of the vertex is 2. You got to calculate the corresponding y. So everywhere you see an x in the original problem, or this problem, it doesn't matter, make sure you put x in parentheses 2. Put a 2 in parentheses. Everywhere you see an x, put 2 in parentheses. 2 squared, that's where the x was, minus 4 times 2. Plus 24. Powers first. Multiplications next. Plus 24. And then left to right order, 4 minus 8 is negative 4, plus 24 should be 20. There's your vertex. 2, 20. Plug that in there, 2, 20, close the parentheses. Make sure you put the parentheses. Hit enter, great job. And they're going to sneak one more thing. The axis of symmetry. Now the axis of symmetry has to go through, that's an ugly looking 20. Okay, let's do it again. 2, 20. That's no better looking. Now you get the point. The axis of symmetry is always an x equals equation because that's a vertical line. See, they're not asking you to actually graph this. They're not showing you the graph. But if you were to graph it, It would be an equation that goes up, or it'd be a graph that goes up, and there's a vertical line in the middle, okay, that is the axis of symmetry. You could spin this parabola around symmetrically. It's always an x equals, so forget the y's. If it's an x equals, it's got to go through the vertex. So the vertex is x is 2. I'm going to go with this guy right there. Not 20, because the y value is 20 of the vertex. The x value, 2. X equals 2. Check your answer. And I guess we're done with this. All right, so I hope you enjoyed Algebra 2 as much as we can with this pandemic going on. But you have till a couple of weeks to finish this up. I hope everybody does, and I hope to see you in school in the fall. And good luck to you guys. All right, take care.